Now learning physics will be great fun with a physics teacher, a solution to all problems in physics.
The physics teacher.
A particle moves along the plane trajectory y as a function of x with velocity v whose modulus is constant. Find the acceleration of the particle at the point x is equal to 0 and the curvature radius of the trajectory at that point if the trajectory has the form of a parabola and of an ellipse where a and b are constants. Now first look in the given statement that what is the important keyword here. So he is saying that this velocity modulus is constant. Velocity modulus is constant means constant. Speed is constant. Clear? So when speed is constant, there is no question of tangential acceleration. There is no question of tangential acceleration because by the definition of tangential acceleration, it is the rate of change of speed with respect to time. And what we have to find out, we have to find out the total acceleration, and let the total acceleration I am denoting here by this letter A, that is equal to tangential acceleration square plus centripetal acceleration square. As AT is 0, tangential acceleration is 0, so we only need to calculate AC in this situation, and the total acceleration comes out to be equal to AC only. And we know that this centripetal acceleration is V square by R. R is radius of curvature here. So in order to answer the first part of the question, for the centripetal acceleration at a point, we need the radius of curvature at that point in both the situations A and B. Clear? So our next target is to find the radius of curvature for the parabola and the ellipse. Clear? So we know that the formula for the radius of curvature as 1 plus dy by dx whole square, and this whole raised to the power 3 by 2 divided by the double derivative of y with respect to x modulus. Clear? So if we calculate this dy by dx and then finding the double derivative means d square y by dx square, we get the radius of curvature. And where we have to find this radius of curvature at x is equal to 0. This is also given. So for this parabola, if you look at this equation of parabola and if I differentiate it with respect to x, so I will get dy by dx, and that is equal to 2ax. And if I differentiate this again, d square y by dx square, so I will get 2a. Now at what coordinate we have to calculate? We have to calculate this at x is equal to 0. So if we substitute x is equal to 0 at x is equal to 0, we get this as 0. So radius of curvature in this situation will be equal to 1 plus 0 divided by this modulus. So this is 2a. So here we have a radius of curvature as 1 by 2a. So the total acceleration part, the total acceleration which is equal to centripetal acceleration is equal to v square by r. R is 1 by 2a, and you will get a total acceleration in case of this parabola as equal to 2av square. Clear? So first part, A part, we have answered. Now for the case of ellipse, we have x by a whole square plus y by b whole square, and that is equal to 1. And from here we can see that at x is equal to 0, y will be equal to b. Clear? Now if I differentiate this equation with respect to x, then what I will get? And before doing that, let me rearrange this equation. Y square by b square, that is equal to 1 minus x square by a square. Now differentiate it with respect to x, and you will get 2y by b square dy by dx, and that is equal to 0 minus 2x by a square. Clear? Now from here, dy by dx, that we need in the numerator for the radius of curvature, so that is equal to b square by a square x by y. Now if I take x is equal to 0, I will get dy by dx equal to 0. Clear? So we need dy by dx at x is equal to 0, and we now know that it is equal to 0. Now the second derivative of y with respect to x, so in order to calculate this, I am rearranging this equation for easy calculation. So I am using product rule here, so I can write y d square y by dx square plus dy by dx into dy by dx is equal to minus b square by a square. Clear? Now we know that dy by dx, from here dy by dx is 0, so this result is 0, and finally we get d square y by dx square as minus b square divided by a square and y. Here we have this y, and this comes in the denominator. Now at x is equal to 0, we have to calculate the second derivative, and at x is equal to 0, y is b. So at x is equal to 0, we have b divided by a square, and as I have taken the modulus, so it is b by a square. So finally the radius of curvature is equal to 1 plus 0 raised to the power 3 by 2 divided by the modulus of the second derivative of y with respect to x, and that is b by a square. And from here I can write r as a square by b. So in this situation, the total acceleration, that is ac, that is v square by radius of curvature, turns out to be v square b divided by a square. So this is our final result for the case of ellipse.